Okay, good morning. Thank you for being here. This is the session, I'm sure you can see it up there, best practices for securing modern cloud applications. My name is Jigar Shah. I'm a product manager at Palo Alto Networks. With me is Narayan, who's going to also co-present with me on some of the features we've recently built. So before we begin, just a quick show of hands. How many of you are network professionals or networking? Okay, so a few of them. How many of you guys are security people? So lots of people wearing same hats, okay. And what about like building applications or owning applications? Sort of, okay. So much bigger audience, which is great because our goal is to sort of show you how security and application teams can work together in this sort of modern DevOps-oriented world, right? So what we're going to show you is obviously a set of best practices and some tools. Don't think of it as just a vendor pitch. You may want to find similar tools that can help you accomplish the same things, right? The idea is to show you what are the practices you want to follow, right? So this is sort of a high-level agenda. Just what are the challenges, then what do you do about it, and then a demo of one of the features. Okay, so this is sort of a common story on on-prem environments, right? Attacker gets into an environment somehow. They try to move laterally to find wherever the value add is. Usually it's the data, and try to extract that data. They also often try to disrupt your environment. You know, there's lots of different objectives. This is one idea, right? So if I take the same thing and move it to the cloud and say, what are the different things I can expect? Relative to on-prem environments, human errors play a much bigger role in public cloud security issues, right? This can be either misconfiguration of your cloud environment itself, not enabling role-based access control, everybody's a super admin, things like that. The two additional dimensions that I like to point out on the lower bottom right on the red colors is that part of the additional challenge with public cloud is that it can increase your costs also, whether it's compute costs, network costs, and so on. And there is a greater likelihood of disruption of services because all your things are running into that public cloud. So unless you've done good segmentation, it's going to be a little harder to reduce the blast radius, right? So in general, from doing 4 years of public cloud security, what we've noticed is these things from a security challenge perspective. One is that most people ended up with fragmented security, meaning on-prem, you've got a great set of tools. You've at least figured out how you want to secure them. But as you add another dimension, public cloud, so you have a completely separate set of controls, security policies that apply in that additional set of controls, and then how do you keep them harmonized? What ends up happening more often than not is most people will go with some kind of manual security controls, right? This is creating accounts manually, individual users being added instead of directory service enabled, addition of users, creating network security groups, all those things become very, very manual. And then how do you manage that at scale? And because it's not visible stuff, right, it's just running in the cloud, people have a hard time understanding what is where, right? So manual security is the one that kind of leads to that human error, that because there's not much automation, and there's hundreds of VMs, lots of subnets, lots of VNets, human error is inevitably going to happen. So all the cloud security incidents you heard last year and this year, I don't think any of them were actual breaches of the cloud infrastructure provider itself. Most of these were misconfiguration, right? Your storage bucket in the cloud gets exposed with confidential data. It was more or less human error because you didn't configure and say there's intellectual property in this storage bucket, right? So, so before we go into deeper dive, I want to run through a few concepts that you may be familiar with. First one's the shared security model, right? All public clouds operate in this principle. Azure does a great job of protecting their infrastructure, the hardware, the network, all those elements are done very well by them. And they give you several tools to leverage, right? So that this could be basically the native security controls like network security groups, WAFs, AD authentication. A lot of controls are built into the platform. So you got to use those. The second part is any security policy or strategy relies on these two ideas of defense in depth and zero trust. I'll go through them in a little bit more detail, but the goal of these two strategies is to disrupt the attacker's kill chain. In that diagram of how the attacker comes into your environment, tries to find the greatest vulnerability or the greatest value data, they're going through a sequence of steps, usually 5, 6, 7. Once they get into your environment, then they make a connection out to the command control server where the hacker is sitting. Then they issue commands. So there's a sequence of steps that go through. I'm sure you're familiar with the kill chain idea. Our goal is that we're trying to disrupt them in at least one place. If you disrupt them in one place, you made their life really hard. They may most likely go away and find something else. Unless it's an extremely targeted attack, then they're going to be really focused and they'll try to find multiple ways. But more often than not, they're all garden variety attacks. Somebody left a VM with admin username, password. Okay, they found it easy, they took it over, they do it, whatever they need to do from that, either do some Bitcoin mining or to distribute malware from it, driving up your network costs. That's the kind of thing they're trying to do, and we are trying to break that. And a lot of things we are going to show in this presentation are really about automation, on how you can use the automation to help you build more secure policies. Okay, so the goal we are driving towards is this. You want advanced application and data breach prevention. So this is going to mean protecting the applications from direct traditional attacks, basically intrusion detection, right? Your Apache server running on the web should be typically patched with the latest fixes that take care of things, but sometimes you're not able to patch them because the maintenance cycle window is too far out or it breaks app compatibility. So you want full traditional ITS, IPS capability and something that protects the data specifically because the cloud has become a big environment where data is stored quite a bit. The second part is that consistency. I mentioned the fragmented security nature. So what you're trying to at least achieve is get a single global view across on-prem, cloud, all these environments. So at least from a policy construct perspective, you want to have similar policies, right? And the last bit is, because cloud is built all about API and automation, you can do a few things manually when you're doing proof of concept, but really the goal is to make it frictionless security, right? So that's sort of the high-level goal. This is sort of a quick overview on the best practices summary that we've developed over time. The first one is you want to include DevOps as part of your security design. I'll go through this in a greater detail, but don't leave the application people out to the last moment and say, okay, I've designed the security architecture, or the app team actually goes and builds out the entire architecture and they call security at the last moment and say, you need to approve this design now, right? So the teams have to work together to a greater degree than ever before, right? We saw this transition even when virtualization came in big time. It used to be that the server guys managed servers, the app people managed apps, but with virtualization, you had both teams having to work together a lot more. Next is the automation, so I've repeated that a lot, so I'll show you details. The third is enabling the native security controls. Don't ignore those. Those are extremely important and complementary. We as a security vendor are not going to say you can replace everything that Azure is providing. They are complementary, right? And I'll show you specific examples. But the most simple one I can say is you should enable the network security group NSG for basic protections, right? Then you want to leverage a continuous monitoring service, mainly because no matter how much automation you put in, there will be mistakes in the automation scripts or errors in the configuration. There'll be humans that go in there and do things. So there has to be something that is constantly monitoring and saying, am I meeting my baseline? If not, it should generate an alert so that somebody can go and take care of that, right? That's where you're constantly striving for a baseline security. Then a little bit more nuanced is that if your endpoints require security, then you should consider endpoint security even in the cloud, right? Because the cloud is essentially your big, large data center, kind of operated by somebody else, right? So usually you need endpoint protection, especially when users are present in that environment, right? Users do all the fun, interesting things. If a VM is never touched by anything and it's completely static with all the application stack you loaded and the libraries, then all you protect is against known vulnerabilities or unknown vulnerabilities. But when users go in, as they do in cloud also, you're going to have zero-day kind of situations, which is where the endpoint capability is helpful. And the last is advanced network security, which is a virtual next-gen firewall that is looking to do IDS, IPS, and much more. So I'll walk through that. So the zero trust concept has been around for a while. Basically, the idea is they're trying to tell you don't trust anything, right? The old idea of the perimeter is the only place where you put security is kind of gone. You want to make sure that you're securing everything inside and outside. For example, in my company, me as a product manager, I cannot touch any of engineering servers. Our networks are internally completely segmented, where as a user, for product management, I cannot touch engineering servers unless I'm granted access, right? And so the question is, how do you apply these controls of zero trust in public cloud, right? Part of the reason cloud is creating this new interesting idea that the perimeter is everywhere, right? Even if you've got a segmented virtual network and you say there's no outside access, I've locked the front door. But the moment you assign a public IP to any VM, it's immediately accessible from the outside, unless you put additional controls, right? So platform as a service components also bring in additional interesting challenges. Pretty much every platform as a service, the most fundamental is the storage, right? The object storage service. And as soon as you put something on there, it's immediately publicly accessible, right? So you're going to decide whether I'm making this publicly accessible or keeping it private to my network, right? Because VNets now have a service endpoint feature, right? So you should consider whether this particular Azure storage blob needs to be externally accessible or it should be completely private, right? So not enough thought goes into that design as you walk through it. I talked about any VM being accessible from the internet, but inside of VNet, the virtual network that Azure gives you, any VM can talk to any VM automatically by default. They built it because they wanted to make it easy enough for developers to start working on it, right? The networking is not super complex. They deliberately made it so that it's easy to consume and use. But if any VM can talk to any VM, then you have no segmentation, which means if one VM is hijacked, you're easily able to move around in the entire network very easily, right? For example, one of the examples on the default configurations is that anytime you create any VM in Azure, even if you have not assigned a public IP, by default, it has an outbound access. It's there by default. It's basically a carrier-grade NAT IP that they assign to you. And if you just do outbound connection, it'll go. Even though you have no public IP on that VM or your entire network has no public IP, it will go outbound. So you want to look at that and figure out what is the accessibility, right? So that's sort of the things you want to think about to say when you have this network running in Azure, what are the entry-exit points, and have you taken the care to secure them, right? So here's sort of how you want to think about it, right? So this is sort of a prototypical cloud deployment. You have several VMs that are servicing your application layer, so web server, application, database, and so on. So these are traditional infrastructure VMs, right, where applications are running. And you're leveraging several platform services like object storage, SQL, caching services, all those things, right? And you may have also connectivity to your on-prem environment via the ExpressRoute or with an IPsec VPN gateway, right? So let's walk through how you want to think about securing this, right? So the first part is that continuous monitoring and compliance capability I mentioned, right? What this is doing is, it's looking at your environment. You give it read-only access or you give it some more permissions. It's monitoring this environment to say, do you have enabled Active Directory with MFA? Have you made sure that your storage buckets are not exposing confidential data to the internet? If you have, then you want to say this is an exception, this is approved or allowed. Have your SQL servers been configured correctly so that they have the right policies? So basically, this is a monitoring service where you put in all the signatures you want it to go check, and it's going to go do check. So we built this service by acquiring a company called Evident. There are similar others that you can go look at. But the idea is they monitor your Azure environment. And then it gives you a compliance report on a continuous basis so that you get email alerts saying, OK, we did not meet this baseline policy, right? So this is the continuous monitoring. This makes sure that anytime mistakes are made, somebody's catching it because nobody has time to go look at this, right? The second element is your applications are deployed, your web services facing the internet. Now your goal is to protect this application stack from attacks coming from the internet. So basically perimeter security, similar to what you do in your data center today on-prem. So this is basically a virtual firewall that does advanced network protection, right? And the third element that I mentioned is that when users get into these environments, which inevitably they will be, like end users like a developer or application tester or an admin even, the endpoint is trying to protect against zero-day attacks and exploits, right? That's sort of the goal. OK, so those are sort of the three dimensions. Now let me go deeper into what a continuous monitoring and compliance service would do. So what it does is it discovers first all your resources and say, what do you have in Azure? And it's continuously doing this, right? It's frequently looking at your cloud environment, and it's telling you what's inside it. And then it's telling you what is the status of where you are. So part of that is compliance monitoring and controls. We don't have enough time for me to walk you through some of the typical things. But if you want, you can go to our booth down on the show floor, and there's a demo of how this product works. But the goal is it's going to look through all your controls, tell you which signatures match your rules and which ones don't, and then it's going to generate alerts based on that. An important part of that is that now we're supporting CIS compliance report so that you're able to compare your organization's status against a best practice benchmark that is created by the CIS organization, right? And a big part of this feature set is monitoring the storage services, right? Like the Azure Storage blobs and page blobs and tables and so on. What it's doing is, you tell us which are the ones you want us to monitor. It's looking out and saying, did you put confidential data in it? Social security numbers, credit cards. So it's basically DLP in the cloud, and it's monitoring this continuously via API-based access. So it's not running a broker or things like that. So it's monitoring for confidential data, and then it's giving you an alert saying, did you mean to expose this to the internet, or should this be completely private? A second part of what the storage monitoring is doing is, it's looking also for malware in files that are in there. So for example, if you've got a web application where somebody is allowed to upload a document file, and then it stores a document file in the storage service. Well, what if they uploaded a malware-loaded file in there? That's what the service is doing. It's basically looking at all the information stored in there, checking for malware, if any of those files, like PDF files, doc files, any of that is in there, right? So the goal is sort of have these three pieces, right? Continuous monitoring and discovery, constant validation against a baseline that you've set, and that storage protection. Because storage has right now become the biggest vector of leaking of data in the cloud. We'll see if new major issues emerge, but storage has become sort of that vector. I can give you another example. Like if you have, for example, a VM that's hijacked, right? If there's a network firewall that's monitoring traffic, then we will see that, hey, this VM that was hijacked is trying to connect to a command control server. The attackers have gotten smarter. What they do is that the malware will just try to write files into a storage bucket, right? So that it's another vector where they will just try to save data into a storage bucket, and then they can go retrieve the data from the open internet from that storage bucket, right? Okay, so the other part of this is that it's got a really pretty dashboard, so it helps you quickly understand what's going on across all the clouds we support, right? So it's basically API-based, so it's going to look through your environment and give you a report saying, for all the accounts, here are all the storage buckets I've got, and what are the issues in that? And when you click at it, it's giving you a drill down of what are the specific security issues, right? So this is way better when you actually play with it than me showing you charts. So try that out, right? So this is the capability, on the storage side, right? I kind of went over this a little earlier. So the goal is that it's going to look through all your storage services and tell you what is exposed and what is not exposed. And it specifically helps you quarantine malware. Okay, so I'm going to move over to the trap side, which is the endpoint protection. The goal is that you would embed this into your workloads for looking for exploits, right? This is basically, you can think of it antivirus, but essentially it's doing a lot more different things because it's not purely signature-based. It's focused on exploits like heap spray or any of the buffer overrun, all these things that are typical exploits. There's like 25 only that kind of exist, and there are millions of signatures. So this thing is much more focused on exploit prevention. Okay, so now I mentioned modern cloud applications, right? So now this is the part of saying, how do you embed the agent for modern cloud applications, right? You have two choices. One is you can do the manual install, which is how a lot of work gets done still, which is bizarre, right? The right ideas are on the two right sides. One is you bake that agent as part of your reference image, right? This is standard stuff. You bake it in the reference image, you deploy it, and it's automated. You don't need to worry about anything. The second option is that you can bootstrap it. As part of the VM deployment, you would say, this is the agent I want you to install, and it goes and installs it. So this is really easy to do. It's not complicated, but I just want to bring it up that this is sort of the basic best practice you want to follow. Okay, now I'll come to the meat of it on the network security part. This is where traditionally there has been, let's say, a lot of fun fights between application teams and dev teams working with security, right? Because security team has a whole baseline policy. They have a process. Oh, you want to open this port on this thing, on the firewall, open a ticket, and then we'll get back to you in 2 weeks. And application teams don't like that. You want to move fast. Wait, they're like, I can create a VM and an entire service in a matter of a day or a week. and you say, I need to wait 2 weeks for just you to approve this one port opening business. So here we want to show you a set of tools that allow you to get there faster. So if you're not familiar with what the next-gen firewall does, I'll give you a very fast overview, right? The Azure NSG gives you port protocol security, just stuff that was invented 25 years ago or something like that. They're basically stateful firewall. What we are looking to do is give you first visibility of the applications. So not port 80, but actually is this web browsing or not? Or something that's trying to go over 443, secure connections. Is this actually web traffic going over 443? Or is this somebody else trying to tunnel out something else, right? So that's number one, visibility. And then you are able to define and say, I want to reduce my attack surface. By that, I mean, so if you have a web application that's facing the internet, you may open 80 and 443 on the NSG, but you may say in the firewall, I only want web browsing traffic to be allowed. There shouldn't be any FTP tunneling over HTTPS or any of these crazy things. Like, for example, if you played with BitTorrent, BitTorrent can go over pretty much any port on the planet. They've made it so wily. So the goal is you get visibility. You want to enable an ability to reduce the attack surface. Instead of port protocol, you want to enable application level controls. And then inside that application stream, you're looking to protect from traditional threats like an IDS IPS. So you have a web server running. Somebody's trying to exploit that WordPress server. What are the typical known exploits? This is traditional IDS IPS, like I said. And the additional capability that has come in the last 5-10 years is that even unknown attacks, meaning things for which we don't have signatures or CVE updates, we use basically a cloud-based service. Basically, it's cloud-based sandboxing for APT attacks that uses that to protect that. So, for example, if there is a malware that is coming in a single file, we are able to send that live to a cloud service. In that cloud service, we open it inside a virtual machine with our probes there. And if that malware tries to do anything funny, we will notice it, and then we'll create a signature specifically for that malware, send it to all the firewalls. So there was an unknown attack, and basically after the first analysis, there's always a patient zero, we were able to create signatures that go to all the firewalls. So next time, any other customer that sees that same attack come through, you can automatically quickly block it. Okay, so let me also give you a quick comparison against the native security controls. Right? I mentioned NSGs, WAFs, and then Azure recently introduced the Azure Firewall. Right? So there are several features that are in there. So we've given you some comparison here so that you're able to get a better understanding of what are the features they provide. Obviously, for full documentation, you should read their docs. We've done a basic quick summary to help you understand and compare what they provide. Right? The basic message I'm going to tell you is you should enable NSGs. Right? That's really important because you can set your baseline security at that point. And then you're going to decide what are the places where I need advanced security because I need full protection, not just port protocol controls. Right? So the simplest example I already said, right? If you have a web application, yes, enable NSG for port 80 and 443. Don't open up all the ports to the internet for your application. And inside that port 80 and 443, that network firewall is going to inspect it and say, is this only web traffic that's being allowed? Similarly, a simple best practice is, if you've got management interfaces, for your admins to get in, either you have a Bastion VM to get in, and on that Bastion VM's NSG, you would set the ACL to your company's IP address range. Right? That way, nobody else can hijack your management servers. But for a fun experiment, if you like, let's say you put up one of my firewalls and then open it to the internet and see how many people try to come brute force you. I'm sure all of you have VMs up there, and you look at the logs, you're going to see that. Right? Okay. So before I go a little deeper on how you would enable modern cloud applications with network security tools, the basic outline of what the typical deployment scenarios for a next-gen firewall are this. You can put the firewall at the perimeter. Sorry, let me go left, right. So you have the hybrid connection, which is your on-prem network connecting into the cloud. So you can think of security at the edge, the perimeter here itself, whatever is your egress point of that ExpressRoute or IPsec. You can apply security right there and then, right? It doesn't have to mean that you're completely trusting this other side of the hand on the cloud side. Because if you want to follow zero trust, you're going to not assume that everything that comes from here on the right side, even though it's your company's virtual network, you don't know what's in there. So you can, on this side, on the organization side, you can firewall that very effectively. And then when you hit the cloud, you have the firewall that's inspecting that traffic coming from the on-prem side, right? Next comes the segmentation capability, right? So this is sort of going into that zero trust idea. So the first level of segmentation is that all your VNet islands, right? You may say one VNet holds one application, or one VNet is for one department. That's the boundary or the blast radius you've created. So when several of these need to talk to each other, for example, in one VNet, you may have all your shared services like Active Directory, file sharing, some of your database services. And then the other VNets are of different trust levels. It's either your development team, your test team, or a partner that are connecting to this shared service. Then you want to inspect that traffic that's going between them, because if you've seen any of the major attacks on retailers, you're a third party that has access to your network. And if you give them unfettered access, there's no inspection, there's no visibility, right? So that's segmentation at a higher level between islands. Now, inside a virtual network, you may need segmentation if you have compliance needs, especially for PCI, PII, or HIPAA, or any of these specific compliance regimes that say you need to inspect between different application tiers, right? Between web server, application, database, and so on. So that's where you can put segmentation. Then comes kind of the major use case for internet gateway, right? Where the firewall's protecting traffic coming in and going out. And that going out is where exfiltration is the biggest concern for most customers. So for example, you've got a workload that's running in there. How do you protect it against somebody connecting to a command control server versus a garden variety software update, right? The last one is remote access, which is just using the cloud's bandwidth of running VPN gateways in the cloud. So I'm going to leave that aside because it's not really targeted at modern applications. So here's sort of practical examples of those things, right? So if you've got a web server that's facing the internet, you can use the firewall to protect against attacks against your web servers, right? So this is standard IDS-IPS, like I said. The hybrid cloud, here's sort of an interesting example, right? For example, if you've got some services that are running in the cloud, including your database service, you can make sure that only the DBA admins can connect to the database server. Nobody else should be able to connect to the database server. So there's a way you can write a security policy in the firewall for that. So we'll walk through an example of that. Segmentation, I already explained sort of that going east to west between different environments of different trust levels, right? And I'm calling out specifically outbound as an example, and we'll see this in the demo, which is to say, when you have outbound connections, there's typically two types. One is usually software updates of some kind. The other is connect to partner systems. So software updates might be like Windows software updates, or if you have a Linux VM, it's trying to get apt-get to use software modules to update on your box. How do you distinguish between that and some connection to a command control server? First, you want visibility, and then you want to enforce controls. So we'll show you an example of this exactly so that you're able to easily figure out how to put these into practice. So now we're going to go into the practice session of how do you secure the cloud apps, right? So before I go in there, I just want to sort of call out sort of the two general paradigms of how things move to the cloud, right? One is sort of a complete lift and shift. Existing app is being moved to the cloud. Some people say, I'm not going to modify a single inch of that whole architecture. I don't know how they do that, because you have to do some adjustments. One of the basic ones I would suggest is to use the Azure load balancers, so that you would at least be able to modernize some components of your application for scale and performance, right? Instead of doing traditional HA, leverage the Azure load balancer so that you get higher availability and higher capacity and performance. But most of these applications should really be moving towards a modern cloud architecture, right? So these things are constructed, using all the Azure services that are available, perhaps also using Kubernetes or any other container-based orchestration environment. But the general look and feel of these is that they're automatable, meaning you have a template to build that stack, and you can redeploy that stack in seconds. If that whole stack is wiped out, you're easily able to replace it. And a lot of these ideas use this idea of immutable architectures, meaning if you have a workload that's running there, you don't go and patch it. You deploy a new image with the patched software, and you just replace it. So it's what they like to call hydration. So they come up with all these jargons, but they're really designed for scale-out architectures. So it shouldn't be that once the stack is broken, you have to manually go in and rebuild that entire infrastructure. It should be an ARM template or a Terraform template that you can redeploy, right? So with that said, I could go a lot more in how we do all the network architectures with network firewalls, but I'm going to just leave you with 2 links to go figure out how we do these things, like those 4 use cases I showed you. So for example, this is showing you a transit architecture where all the firewalling lives in a hub, and all the spokes is where all the application services are living. And so you can use a common stack of firewall in the cloud that helps secure multiple VNets. But I'm not going to walk through all these things because that'll be a whole different session. But essentially, there are ARM templates available in the GitHub repo for you to go play and figure out. But I want to now pivot to sort of a more detailed dive on saying, how do we help the security teams and the DevOps and app developers work together, right? So if you follow the cloud journey, you know there's still this thing called a shadow IT, right? The line of business application owner says, I have a credit card. My app team can go and build everything they like. There's no security guys in there. So they just go build stuff, and which means they do fun things. Even my developers sometimes do that. They're like, I just created a VM for testing something. They leave it running for the whole weekend with a public IP, and any attacker can come attack it, right? They're not going to put in all the security best practices, right? Because their focus is something different. Their focus is to build the apps, right? So in general, that initial idea I said about the 2 teams working together, we've talked to lots of CIOs and CISOs, and we've noticed these 2 best practices. First is, there's a security expert that is assigned to each application development team or a business area. And that person participates in all their architecture reviews and blesses their design, saying, you designed this right, OK, you need to put this control here, you need to do this. They live and actively participate. So that's model 1. It does require a lot of security people because you have to participate actively and contribute, because otherwise, they're just going to do their own thing if you just attend one meeting and then they go do their own thing, right? That's one. Second is a little bit more, call it a distributed and give everybody the right or the trust, and then they will do the right things idea. The idea is that in each application team, you train a security champion, you enable them, you give them training, they have the expertise, and now they become kind of the owner inside that app team. And that way, you have a baseline set of policies that you've given, everybody follows that. So you need to figure out which one works best for you. Maybe it's a journey, you start with number 1 for a while, and then you move to number 2, right? So this is something we've heard from CIOs and CISOs quite a bit. If you're initially going into the cloud, maybe number 1 is a better option. Once your teams get a little more mature, maybe number 2 is the better option over time. OK, so now sort of the little bit of details on how we can help sort of that DevSecOps, right, another jargon word, to happen. So the goal is, if you want to automate security as part of that CI/CD process, what they like to call build, ship, run, you want to integrate the firewall and all these controls as part of the design. And if you're using firewalls, then you want to centralize all the management and the logging, because the firewall should also be just like your application components. Use and throw, essentially immutable, right? And one of the key features we've built on this is the dynamic security policies. The idea is, as workloads come and go, you shouldn't have to create new security policies. That service ticket business that I mentioned, you don't want that, because when an application auto-scales, okay, there's a whole bunch of new IPs that are going to show up. How do you make policy aware of those new machines and say you're allowed to connect to those machines? And when they scale back in, how does the policy dynamically adjust, right? You don't want that business of somebody opening a ticket every time something new happens, right? So this is an overview of the different kinds of automation tools that are possible. So first is that you want bootstrapping of the security appliance so that it can completely automate the firewall policy. It does not need to be that you deploy a box, then somebody manually logs in, configures it, all that, right? So bootstrapping is an automation fundamental. Then moving down, all the security tools should have a really good API, right? Cloud has really good APIs, so you want APIs. These are standard RESTful APIs, so you should be able to make a standard HTTP call to that after doing authentication, and then you can issue commands to it. But some people will say, OK, RESTful XML API, that's a lot of work. I would like something simpler, because scripting-wise, Python is probably a whole lot better and easier for a lot of people to ingest. So whether it's Python, Ansible, or Terraform, there are several automation tools you want to help that automation. Then we come to the bottom, which is sort of an ability that typically what you want in the firewalls is they should know your entire list of whitelists and blacklists, IPs and domains. This is the idea that you may say, I don't want my service to be ever talking to these IP addresses. These are all malicious IPs that we are getting as a feed from FBI or CERT or any of the resources. You should be able to feed in an entire set of information to the security appliance so that you're not manually uploading all these things, right? So that's sort of on the operations side of the security. Now, that dynamic policy update feature I mentioned, it's built on this idea that all your cloud resources have a lot of tags and context information. We should be able to leverage that to create dynamic security policies, right, using that metadata of the VMs. We'll go into the detail on that one in a minute. And the last one is, especially for incident response and automation, you want the security tools to be able to automate into your environment. So for example, if you see a particular kind of malware, or if you see certain type of attacks happening repeatedly, you want to take an action on it and not sort of, go through millions of lines of logs to find, oh yeah, there's the bad thing. Can you automate that? So for example, one of the ideas we do is, in the logging system, you can set all the filters you want to say, these are the things I'm looking for. If I see these type of malware, I want you to take this action. Essentially, it's just a simple HTTP post. For example, it can launch an Azure function that can go and quarantine that VM. Or it's an HTTP post to your service desk or ServiceNow system that creates a ticket for somebody to go and investigate that, right? So there are some examples of this in our GitHub repo. I'm not going to walk through those. But I want to show you the automation pieces, right, on the firewall. So the first thing I mentioned was the bootstrapping feature. So here's how we do it. There are several other ways you could do it. So one idea is you take the security policy, licensing, software updates, everything. You put it in the Azure file storage. And when that virtual VM is booting up, it's going to read that using the storage access key and fully configure itself. And it will also attach that VM to the management server panorama so that when the application team is deploying it, they're going to bake the security firewall as part of their design. And then once the VM is up and running, fully configured, it's going to attach itself to the management server for firewall management, right? And so to help sort of that management work easy, if you remember, I mentioned that earlier idea of centralized management, right? So you want a management server that works across the board in different environments. So you can choose to use your on-prem management server, or you can run a specialized management server in the cloud. So the goal is you should be able to run that single management server everywhere. Okay. So now we're going to come into that whole part about how we automate security to work with DevOps-style sort of application development. So this is that VM monitoring feature that builds dynamic security policies. So for that, I'm going to hand over sort of the presentation and a demo to my colleague Narayan, who's going to walk you through that.
Thanks, Jigar. Can you guys hear me okay? Yes? Okay. As Jigar covered, we are actively trying to evangelize this concept of infrastructure as code. You can do infrastructure as code with these Terraform templates or ARM templates and make these architectures immutable, make your entire infrastructure immutable, right? So tomorrow if you have a breach or tomorrow you want to patch your system, you don't go and patch your system, you just go and delete this, you just kill them and then you redeploy them with a patch system. So there's another concept that Jigar kind of touched on. It's called treat these things as cattle and not pets, right? Just slaughter them, create new ones, go for it, right? Now the new infrastructure is patched, it's ready, security is automatically applied. We also want to evangelize this concept of security as code. You want to bake security far left as possible, right? Well, when you're building your application, you want to build it securely so that you don't have to worry about it, so that when you go from your build to your test to your deployment stage, that you don't have to think about whether I've ever actually baked in the right security policies or the security parameters that are required by my company. So we notice that the workloads in cloud are ever changing. It's never going to be static. Your data center might be fairly static, but the cloud is never static. VMs are coming and going, especially if they're auto-scaling. There's lots and lots of churn that happens. Some VMs are very short-lived, maybe an hour, a day, a week. Some VMs may be long-standing, like your shared services VMs may be long-standing. All of these VMs have metadata that is associated with them, right? And you want to build policies based on this metadata and not IP addresses, because IP addresses could change at the drop of a hat, right? You don't want to say, allow 1.1.1.1 to talk to 2.2.2.2, and then tomorrow 1.1.1.1 is not 1.1.1.1, right? But you want to be able to say, allow my web server to talk to my database server and not my database server to talk to my web server. That makes a lot more sense when you're writing a policy. So what we want to do is, in the firewall, we have something called a dynamic address group. A dynamic address group is just an object in the firewall that you populate with certain tags, or these metadata that you can see. It says, hey, I have a MySQL server in New York and a web server in Miami or what have you, and I want to be able to let them talk to each other in a secure fashion. Or my web server in Miami should be able to talk to my web server in New York, or never. So you can create these dynamic address groups, and we can determine group membership based on these IP addresses. So we will automatically go and pull in this IP address and all the metadata that's associated with these compute resources, and we'll populate them in the firewall, and now allow you to write these, logical policies to say, New York, talk to Miami. New York, don't talk to, New Orleans or whatever. Right. So what do we want to do this? We want to do this at the speed of DevOps, right? You want to, as I said, you want to move all of this stuff back to the left. You are doing this as your developers are building this code, as they're building the application. So one of the things could be a developer, pushes some code into a code repo, and at the same time, your firewall admin or your security team admin has, committed a security policy. Now, this security policy can be can fire off a Jenkins job. It says, hey, you know what? The developer wants to push some code in. I'm going to stand up a VNet. I'm going to put a VM series firewall in there, or a next generation firewall in there. I'm going to bake in bootstrapping with the right policies that the developer wants. The developer wants, 1533 open for some odd reason. I will allow them to open 1533, but only allow that IP address from corporate IP, or that user ID from that developer's user. Now, all of this is happening in parallel. There has to be some coordination involved between, because now the security team could say, hey, I'm overloaded. I can't do this today. I'll have to do it a week later. The developer gets angry, escalates it to their manager. Some CEO gets involved and says, hey, how come you can't keep up with the speed of application development? Like, security has to be fast. One of the things, and the other thing that Jigar pointed out is, you want the security folks as part of the DevOps people, right? You want DevSecOps. You want people trained in security. People should be thinking about security as they're pushing things into the cloud. We should not think that, hey, this is just a development machine that I'm just going to leave it out in the open. Whatever. If it gets hacked, there's nothing in there. No worries. I'll just kill it. Now, think about this. If you have a development machine that has admin as a username and password, but that VNet that the machine is living in is peered to another VNet that has some sensitive information. Lateral movement is extremely easy, and if you don't have the proper security controls, an attacker can move from one VNet to another VNet back to your corporate unfiltered, and they have unfettered access, right? You want to prevent that, and so you want to make sure that you're training the developer to say, look at it from a security standpoint, but then give them the tools to enable security at the very beginning so that security doesn't become a bottleneck. So, as I said, we're harping onto this to bake security into the CI/CD process, right? We have this feature called VM monitoring within our centralized management platform called Panorama, where you can point Panorama to an Azure subscription or other cloud providers and say, go build this IP tag information, get all this metadata for all the compute resources that are running in my Azure subscription, and I will write policies based on this. And you can, with our APIs, you can even automate the policies with, we're a Terraform resource provider, so you never even have to touch Python. You can just use Terraform to, configure the firewall fully. You can use bootstrapping to say, bootstrapping is just a big giant XML file. So you can, once you've written your security policies, you can go manually update the bootstrap file, or to apply new security policies. So as the firewalls are coming up, they automatically have the latest and greatest security policies that your team needs. We natively publish firewall metrics into application insights. So use application insights to gain visibility into, is my firewall being overloaded? Is it doing way too much work than is necessary? If so, A, it might be a problem, or B, it may be like, hey, you know what, that's great. My application is getting a lot of traffic, so I need to automatically scale. So you can set up auto scaling based on application insights. And as Jager mentioned, you could do action-oriented log forwarding. You can trigger based on an alert that you've seen that says, hey, you know, bad user is trying to move from VNet A to VNet B. They're never allowed to do that. They're trying to do some brute force attack or trying to guess passwords or whatever. Now move this user into a bad IP list so that they're blocked for 24 hours, 48 hours, that kind of thing. Or open a ticket to say, you know, go fire this guy, whatever. So one of the things that we talked about is GitHub. GitHub is fundamental to the CI/CD process, to DevOps. Everybody posts things on GitHub. We post things on GitHub, and I am guilty of this too. I never think about what the heck is it that I'm pushing to GitHub, right? Sometimes it's a simple thing like, you know, some of my colleagues want a very quick template or some script. And I said, you know what, it's easy. I can do it in an hour. Here, I post it. I make it publicly available, you know, then post it on my resume, whatever. All of a sudden, I realize one guy calls me and says, hey, you know, you have your username and password for your VM in your GitHub template. Or you have your SSH key in your template. You know, so there's no scrubbing. Like, you know, I made this mistake. I didn't go through my template. I didn't think about it. It was quick. It was dirty. I just needed to push it, got the job done. Kudos. Everybody was happy. But I didn't think of these things. Now, if you have a continuous monitoring service that's monitoring these storage buckets or GitHub repos, it will create an alert that says, hey, you just pushed an SSH key into your GitHub repo, right? We'll scrub it out. You know? I automatically get a ticket. I get an email from the ticket that says, Security has noticed that you pushed an SSH key. Go clean it, right? You can create these alerts. You can scan for confidential information. Maybe I accidentally, you know, put my credit card number in there for whatever reason, right? And you can go scan these. So we talked about you want to be able to build consistently your infrastructure. Every single time you want the same infrastructure to be done because you've spent a lot of time architecting your infrastructure. You want it to be immutable. Don't go patch the infrastructure. Kill the infrastructure and create it again. Bootstrap everything that's possible so that your infrastructure comes up configured, ready to go, and embed agent into the workloads if you're doing endpoint protection. You want to be able to segment based on apps. You know, you want to extend zero trust as much and as deep into your infrastructure as possible. We do that already in hybrid. We do that in our private data centers, but we fail to do that in the cloud. So we want to extend that zero trust all the way down. Use the APIs that everybody provides you to automate all of these things. Never have manual intervention because manual intervention is prone to human errors. And then continuously monitor. Set up a baseline and continuously monitor for drift. Maybe that drift is okay and then you need to set a new baseline, or maybe that drift is bad and you want to be able to catch that. Right? And then use cloud native things like auto scale based on triggers, right? Don't think traditional networking, traditional security, traditional application development. Think modern, think native, think highly available. It doesn't have to be that your session states are synced between one web application and the other web application. It'd be okay if one web application dies and the sessions have to be reestablished with another web application. Use auto scaling, use native load balancers, because they have a lot more scalability because they're plugged into the fabric, right? Use automatic security, that security gets automatically updated as and when your infrastructure changes, right? If VMs go away and they come back in, your security doesn't have to change. If you're using Kubernetes and your Kubernetes cluster dies, or if you spin up 100 nodes and 1,000 pods within your Kubernetes cluster, you don't want to change security for those 100 nodes and 1,000 pods. It's automatically applied because you baked it in while you're building your entire infrastructure, while you're building your application. So just based on that, I wanted to quickly demo this feature that we have called VM monitoring. So we talked about dynamic security policies using VM tags. IP addresses are no longer useful in the cloud. Everything is identity-based, everything is service-based, everything is tag and label-based. And you'll notice that more and more and more as you go into take your monolithic applications and break it down into microservices. Everything is label-based. They say everything is identity-based. You say, label XYZ wants to talk to label ABC, right? No longer it's IP address to IP address. So, sorry, let me go back. Can I go back?
That's fine. You can just describe this.
Okay. So what we've done here is it's a very, very simple setup. It's a traditional two-tier application, a web server and a SQL server in a single VNet and fronted by our VM series firewall. And the VM series firewall was bootstrapped to automatically connect to our centralized management platform called Panorama. Now, that is the only thing I did for bootstrapping. What has happened is Panorama detects that a new firewall has connected to it, and it automatically pushes whatever security policies, licenses, updates, whatever it needs down to that firewall. No action required on my part, right? Let's see. So VM series, two interfaces exposed to the outside world. One is a management interface. One is just a traditional data plane interface. That's where all the traffic comes in. The web server and the database server are behind the VM series in two separate subnets. And as I said, it's connected to Panorama. So sorry, I went too fast. Okay.
Okay.
Oops. I don't know how to play this.
So like a video player at the bottom?
Yeah, I don't see controls for the video player, so I can't.
Yeah, well, I guess we can wait 30 seconds for it.
Right. So as part of this feature, what we're able to do is you go configure your Azure Service Principal, and you with just read credentials. That's all we need. And then when you set it up, you can say that I want to monitor subscription 123, and here's my service principal for that subscription, and that's all it needs. And then you enable this feature. Once you enable this feature, it automatically goes, and you have the ability to tweak the timing, whether you want it to do it every minute, every 2 minutes, every 5 minutes, whatever you guys decide. And we will go and pull all of this IP and metadata information into the firewall, into Panorama, actually. And now what you can do is you can write security policies itself within Panorama using these objects that are created. And we'll get to that. So what I'm telling here is, once I receive an IP tag update, I want it to send it to this device group. A device group is exactly as it sounds. It's a group of firewall devices that are clumped together. So you can have a whole bunch of your Azure firewalls or even your hardware firewalls all clumped into one device group, and you say, as soon as you receive any sort of IP tag update, send it to this device group. Here you can see a bunch of security policies that talks about, allow Linux outbound, and says, anything that is marked as Ubuntu production coming from this particular zone, only app apt-get, nothing else, right? Now I can do things like SSH inbound into my firewall, or SSH inbound into my Linux production systems. And then what I can do is I can do some sort of destination NAT and say, punt it to a different port. That way the firewall is now fronting all of your SSH traffic as well. You can see other, like line 4, you can see there's a thing that says, from web to DB, allow from web production to DB production, right? But then at the very end, I have a default deny policy. If none of these security policies match, the firewall is going to drop that packet. I can even add an explicit policy that says DB production to web production, deny. That way I create an alert based on that, if I so choose to. Here are some address groups that I've created. One is for database production, and then these are the tags. It says, if my Azure OS type is Linux and my tag status is production, then this IP address belongs to this address group. And here you can see all of the tags that we pre-populate. Some of them are predefined tags that we generate, and then we collect up to 30 user-defined tags. So you can create your own tags rather than relying on what Palo Alto Networks creates, and then populate them into that address group. Now these address groups are continuously updated. So when a new VM spins up, and if it matches these tags, the IP address is automatically added to that address group. That address group is part of a security policy, and now that security policy applies to that new VM that got spun up as well.
Show the screenshot of the Azure site to say these tags are actually coming from Azure.
Right, yes. I think we missed that on the recording. But here you can see some of the logs. I'm going to log into one of the servers on port 221. This is my one of my Linux production servers. And from here, I'm going to try and do a simple just apt-get update, right?
Yep.
It goes through just fine. But and then I think we also missed doing something else and then having it blocked, but that's okay. So here I can go and install something, and then if you flip back to the firewall, refresh my logs, and you'll see that that web server or that Linux server went and actually tried to do an apt-get. And you can see other logs in there that says, hey, somebody was trying to do web browsing on port 80, allow that because I was doing outbound access from that Linux firewall.
I think you can pause there. So I think essentially what we're trying to show is that the Linux VMs were tagged as Linux because we fetched that tag from Azure, and it was tagged as production. And so when we did an APD get, the firewall saw it and said, oh, you're coming from this IP. It looks up and says, you match this particular security policy, and so we're going to allow you. What Narayan was mentioning is we could have done a converse example also to say, now if I flip the tag out, it should block it right away.
Anyway, some of these things are easy to play around with, and we have multiple booths, multiple demo pods down at booth 606 on the expo floor. So feel free to stop by, and we can talk about other things, the things that Jigar mentioned about Evident and Aperture, trying to do continuous monitoring. We have a demo about how do we secure Kubernetes clusters and endpoint. If you guys are interested in endpoint protection, we have a demo booth for traps. So we have a lot of information out there. So to summarize, all teams, including DevOps, including security, need to be present in the application design phase. Is what we really need to strive for. Secure during build, secured by design is the thing that you want to preach internally within your company. Don't think security should be at the very end or security should be deployed at the very end, and then security should never be a bottleneck. Security should be transparent and should be automated as much as possible. Enable native security controls, NSGs, RBAC, encrypt things at rest. Azure provides a lot of native security controls. And think about defense in depth, right? Always think defense in depth. Always think what happens if my perimeter gets breached and somebody has unfettered lateral movement, right? You want to extend zero trust into every single subnet as far into your infrastructure as possible. Enable a continuous monitoring service, whether it's Evident or there's something else. You're continuously monitoring for drift. You're continuously monitoring to make sure that things are going according to the way you had initially set up on day 0. That day 10, it's the same security posture and nothing has drifted. Right? Nobody has spun up a VM with admin, or nobody has created an S3 bucket with some PII data in it. Enable advanced network security. You want to prevent inbound attacks and outbound exfiltration. You want to prevent. You want to have some sort of agent on your endpoint that can do zero-day exploit prevention. The advanced network protection can prevent known threats. What about unknown threats? What about zero-day exploits? Right? And lastly, it's all about automating security. Everything should be automated in the cloud. Nothing should be manual. Your app development is already automated, right? Why not security? You want to be able to centrally manage your firewalls and logging. You want to see everything as possible. If you can't see it, you cannot protect it, right? And then you want to use dynamic security policies. Security policies should never be stagnant and static. It should It should iterate with your cloud. It should iterate with your workloads. Right? Lots of information available at azure.palo-alto-networks.com. We have a lot of templates and examples on how we try to achieve automation of security in our GitHub portal, on our live page. That's it.
Right. So if you have questions, there are 3 microphones. Feel free to come ask us or talk to us afterwards. Thank you.